Hi friends, I am Shunsureshkumar. In this video, I am going to solve questions from chemical bonding. I have posted these questions in my chemical bonding part 1 video. Today, I am going to solve these questions. Okay. Let's start from the question number 1. Which of the following molecules are all the bonds are not equal? All the bonds are not equal. They ask only the bonds are not equal. Okay. So in my previous video, I have explained the molecules which have trigonal bipyramidal, octahedral, pentagonal, bipyramidal. These three geometry have different bonds. Two different bonds. One is axial, another one is equatorial. Axial bonds and another one equatorial. Axial bond is differ, equatorial bond is differ. Okay, so this is the clue here. So here, in which of the following molecules are all the bonds are not equal? So if the molecules have any geometry like trigonal bipyramidal, octahedral, pentagonal bipyramidal, we have two type of bonds. Okay, so that is the clue. So here ClF3, we can check ClF3. So we know how to find hybridization. Here chlorine is the central atom. So central atom chlorine comes into 7th group. So the valency of chlorine is 7. So 1, 2, 3, 4, 6, 7. Fluorine 1, 2, 3. These two are lone pair electrons. Hybridization H is equal to number of bond pair or sigma bond 3 plus 2 lone pairs. So H is equal to 5. So sp3 dehybridization. sp3 dehybridization. So we know the structure: chlorine, fluorine, this lone pair electron, this lone pair electron, this fluorine, this fluorine. So this lone pair electron and this fluorine are in the same environment. Okay, so this axial position, these two fluorines are axial position, this is in the equatorial position. So two different fluorine atoms are there, so two different bonds are there. Okay, let us check another option. This is option A. Option B, BF3, boron trifluoride. Here boron is a central atom, so that comes in the third group. So valency of boron is 3. 3 fluorines are occupied here. So the valence is like that. This is the structure of boron trifluoride. So all these three bonds are same. Okay, so option C, AlF3. AlF3 also comes under the third group. Aluminum also comes in the third group. So valence is 3. So the structure of aluminum fluoride is like this. So these three bonds are same. And check NF3. So nitrogen trifluoride. Nitrogen is a central atom, comes under the 5th group. So valence is also 5. 1, 2, 3 fluorine, 1 lone pair electron. Hybridization is equal to 3 plus 1. 4 means sp3 hybridization. sp3 means tetrahedral geometry. Okay, what about the one lone pair is there? So the shape is different. Fluorine is the pyramidal shape. Okay, one lone pair is like that. It's a pyramid. But all three nitrogen fluorine bonds are same. All nitrogen fluorine bonds are same. Here aluminum fluorine, all aluminum fluorine bonds are same. Here boron fluorine bonds are same. So the option A is the right option. Okay, so the similar type we can answer the last 15th question also here. Okay, so 15th question also have the same type. So they ask the NMR. Okay, if ClF3 were to be the stereochemically rigid, its fluorine 19 fluorine NMR spectrum would be the, so they ask the fluorine spectra. Okay, the ClF3's fluorine spectra. So we know the structure. Here you can see the structure of the fluorine ClF3. So two different environment. Okay, so two different environments, we can expect two NMR signals, so these two options ruled out. So we can check we know the formula for NMR. So this is the N1 plus N plus 1 formula for splitting. This is splitting formula. So I will explain this in the NMR spectroscopy. This is a chemical bonding, so I don't go for deep. So here this for Fe, so neighboring fluorines are 2. Okay, so N2 plus 1, 3 signals. 3 means triplet. So here if axial, so that is these two Fe, axial fluorine, this is equatorial. Here neighboring fluorine is, neighboring atom is fluorine, one fluorine, that is fluorine equatorial. This is equatorial. So 1 plus 1 is equal to 2, doublet. So the option is a doublet and a triplet. So these are the advanced questions. These asked in the GATE exams. Okay. So we can, if you know the geometry, we can answer the NMR question also. So here next question: which one of the following molecules contain no pi bonds? No pi bonds. They ask pi bond. Okay, double bonds or triple bonds. Here we can check. C double bond O, H2O, SO2, NO2. So if anyone can answer this, but in the chemical bonding, if you know the chemical bonding, you can apply the concept and you can answer the question with the concept. Okay, you can check here. Oxygen is here, carbon is a central atom. Here sulfur is a central atom. Here nitrogen is central atom. So oxygen give two bonds, so makes double bond. But here hydrogen is a neighboring atom. Oxygen is a central atom. So other three option, other atoms are central atom, but here this is oxygen is a central atom. So oxygen H2O, oxygen is a central atom, so comes in the sixth group. 1 2 3 4 5 6. So hydrogen, one hydrogen, 2 makes hydrogen bond. Okay, hybridization 2 plus 2 is equal to 4, sp3 hybridization. So this is the structure of water molecule. Okay, this is the structure of water molecule. This is the angular shape. Okay. So the option 2 is the right answer. Next, the total number of lone pairs of electrons in I3 minus. They ask total number of lone pair electrons in the given molecule. Okay, so I3, here center atom is I. Iodine comes under the seventh group. So 1 2 3 4 5 6 7. Iodine 1 2. So this one negative, so put 1, this 2. So here everyone answer that 3 lone pairs. Okay, so here they are immediately answer 3. So if they ask only the total number of lone pairs, that means all atoms lone pairs. Okay, so don't blindly answer these 3. So you must answer like this. The hybridization H is equal to 2 plus 3. 3 plus means sp3 dehybridization. sp3 dehybridization means iodine, one iodine is like this, one iodine is like this, one iodine like this lone pair, this lone pair. Okay, one this also in one lone pair. So this is in the linear structure. So here 3 lone pairs are in the equatorial position, 2 iodine atoms are in the axial position. So here we know the valency of hydrogen iodine is 7. 1 2 3 4 5. This is 5 6 7. So here 1 2 3 3 4 5 6 7. So total number of lone pairs 1 2 3 4 5 6 7 8 9. 9 lone pairs. Okay, so they ask on total number of lone pairs. Many students do mistakes in this question. This is very simple, but they ask trickyly. Okay, so 9 is the right answer. Next, number of lone pairs are identical in the pairs. So we need to know the pairs, how many lone pairs in the pairs. So option A, XCF4 ClF3. Okay, so we can check XCF4, central atom is xenon, comes under 8th group. So valence is 8. 1 2 3 4 5 6 7 8. fluorine 1 2 3 4 lone pairs. So here they only ask the lone pair, so don't bother about the hybridization. Next check ClF3. Chlorine is the central atom. Chlorine comes under 7th group. So 1 2 3 4 5 6 7 1 fluorine. So lone pair electrons. So 2 lone pairs. So these two options have the same number of identical lone pair electrons. You can check other options. So other options don't have the lone pairs are not equal. Okay, you can check the other options. Next, in the angular shape of oxygen, O3 consists of. So oxygen, so they give the clue the angular shape, and they ask the type of bonds, sigma bond or pi bonds. How many sigma bonds are single bonds and pi bonds? Okay, O3. So here oxygen is the central atom, comes under the 6th group. 2 3 4 5 6. One oxygen coordinate with his like this, another remaining is this. So hybridization is 2 plus 1, because 1 sigma bond 1 sigma bond. 2 plus 1 3 means sp2 hybridization. So geometry is angular, so angular, that is confirmed, and the shape is angular. So we can check the structure like this. Okay, so here one bond is not is double bond. Okay, so because it's a resonance structure shows that one is positive, another one is negative. Okay, and its bond order is also different. Bond order for this ozone molecule is, this bond is 1.5 bond order. Okay, bond order for this oxygen bond is 1.5. That is not a complete single bond, so it's complete double bond. Okay, if the bond is double bond means 2, bond order is 2, but here the bond order is 1.2. Okay, and the bond length also same for this oxygen bond length is also same. So so the here the answer is 2 sigma bond and 1 pi bond. Okay, so next, which of the following species has a linear shape? They ask the shape of the molecule. Okay, so option A, NO2 minus. Here central atom is nitrogen. One comes under 5th group. 1 2 3 4 5. One negative charge, so put one negative. One not oxygen lone pair. Okay, hybridization is equal to 2 plus 1 equal to 3. 3 means sp2 hybridization. sp2 hybridization means, so the shape is 1 double bond so they ask only the linear shape. So we don't get the linear shape for sp2 hybridization. Here one lone pair is there, so this comes in the angular shape. Okay, lone pair, so that comes in the angular. Okay, next check the second option B, SO2. Sulfur is a central atom. Sulfur comes under 6th group. 1 2 3 4 5 6. Oxygen, another one is the lone pair. So 2 plus 1, so 3. So similar is also comes in the angular, so that is not a linear. They ask only the linear. Then check third option in NO2 plus. NO2, nitrogen is central atom. Nitrogen 5. 1 2 3 4 5. So 4 5 is not. Okay, O. So here nitrogen NO2 plus, so we won't consider this. So hybridization H is equal to 2 plus 0. So 2 means sp hybridization. Sp hybridization structure is like this, NO plus. So this is a linear structure. Okay, so we can check D option, O3. So the O3 also we recently previously calculated, that is angular shape. Okay, so that is an angular positive. So this is angular. So the option C is the right option. Option C is the right option. Okay, so next video I will continue the remaining problems. Thank you.